Okay, all right. So in this video, we're gonna a bit deep dive into binary numbering systems and decimal numbers. So I think it's gonna be simplified for every person who listening and watching this video. I hope so. I also trying to understand the easy piece things, not too hard. Okay. So what is binary numbering system? Binary number system is basically used in computer. It's kind of like a computer language. So people can speak different kinds of languages. Computer also has his own language. He can only understand just only 0 and 1. If it is 0 or if it is 1, just only two numbers, two digits, 0 or 1, just it. So no more than that, he does not understand anything else, you know. So kind of like we are even write programming languages, but the computer does not understand. Computer does not understand what we say, what we instruct. He only understands because of compilers helping him like that. So okay, we will try to understand binary numbering system. So like I said before, computer only understands 0 or 1. If it is 0, it's gonna take also 1 bit. If it is 1, it's gonna also takes 1 bit. It's for data storage. So that's why we have to understand, like, because full sorry 8 bit gonna be equal to 1 byte, right? We know that. Okay, so how does it happen? So here we can calculate the possible values for data types that are like equations, kind of like, okay, in 1 bit, because binary number system is just only two, 0 or 1. So that's why we had to apply um, base 2 system. We had to apply base 2 system. Base 2 system. Okay, all right. So we had to apply base 2 system. So it's gonna be 2 to the power n. It's gonna be 2 to the power n. Okay. If it is 1 bit, it's gonna be 2 to the power 1. 2 to the power 1. So 2 to the power 1 is gonna be 2. So the possible value for 1 bit is 0 or 1. Right? So how about 2 bit? 2 bit is gonna be 2 to the power 2, right? 2 to the power 2 is gonna be 4. So the possible values are 4, because like 0, maybe 0, 0 1, maybe 1 0, maybe 0 0, maybe 1 1. This is a possible value for 2 bits, right? So how about 4 bits? It's gonna be in the even numbers, right? So it's gonna be 2 to the power 4. So it's gonna be 2 times 2 times 2 times. Okay. So the possible value is gonna be 16 values between 0 0 to 1 1 1. So 8 bit. So 8 bit is gonna be the possible value is 256, right? 2 to the power 8 is 256, right? So the possible value of 256 value from 0 0 0 0 8 times 0 8 times to 1 8 times. That's it. So 8 bit is equal to 1 byte, right? So that's the computer understand about the data storage. So here one more thing is, how do we understand, how do we change a decimal number to binary number? So I say before, computers only understand just 0 or 1. So that's why they only make executions based on 0 or 2. So it, basically it's based on 2, right? So okay, let me change 15 um, decimal 15 value to binary number, right? Okay, let we understand this. We're gonna change 15 to binary number. What we're gonna get? Okay, we will divide it by 2. Okay, divided by 2. So the quotient value is gonna be 7, right? So if we subtract by 14, it's gonna be, the remainder value is gonna be 1. And this time again, we will divide it by 2 until the quotient value is 0. The quotient value is equal to 0. So until this time, we will multiply by 3. The quotient value is 3, right? So 2 times by 3 is gonna be 6. So 7 minus 6 is gonna be 1. So the remainder is gonna be 1, right? So we can keep dividing by 2, right? 2 this time 2 times 1, right? So it's gonna be 2 times by 1 is gonna be 2. 3 minus 2 is equal to 1. Okay, the last time. So this time we're gonna put like 2 times by 0, right? So this time also the remainder is gonna be 1, right? This is the end, because the quotient values is equal to, right now, equal to 0. So this is finished. So how do we get the binary code? So we will get the binary code like reversely, from up, not from up to bottom. We had to take it from down to up. So we're gonna take like this. We're gonna take like this. We will reorder these numbers again. So 1 1 1. So this is binary codes. The computer understands. So 15 decimal value equal to 1 1 1. Yeah, that's it. This is decimal. Sorry. This is decimal. This part is gonna be a binary. Okay, you guys can understand? I think so. So how about to change from binary codes to decimal numbers? Okay, we will change again this. How are we gonna change? So we're gonna change 1 1 1 1 2. Okay, how are we gonna change it? So I say like it before, the same again here, the same plans here. So we will start from left to right. So we're gonna start from this left side 1. So we will start from 2 to the power 0. 2 power 0. We're gonna start from 2 power 0. We're gonna start from for another 1, 2 power 1. This time 2 to the power 2. This time 2 to the power 3. So we will multiply for each number. So we start from left to right. Okay, we're gonna start from left to right. So for the first number 1, we multiply 1 multiplying 2 to the power 0. So it's gonna be 0, right? Or it's gonna be 1, right? So we will go to the second one. So 1 multiplies 2 to the power 1, right? So it's gonna be, the value is gonna be 2. The resulting value is 2. So for the third one, 1 multiplies by 2 to the power 2, or 2 square, right? So it's gonna be, the value is gonna be 4. So for the fourth one, so we will 1 multiplies by 2 to the power 4, 2 power 4. So it's gonna be 8, right? Or it's gonna be, sorry, not 2 to the power 4, it's 2 to the power 3. So it's gonna be 8. So 8. So we get the sum value of for all of the number. So 1 plus 2 plus is 3, 3 plus 4 is 7, 7 plus 8 is 15. So if we change again from this number to decimal number, we get the 15. So this is the relationship between the binary codes and decimal numbers. So computer cannot understand directly 15. They have to change from decimal number to binary codes. So this is the relationship between binary codes and decimal numbers. So in this video, okay, this is enough. I think in the next video we can go to hexadecimal and to binary codes, or binary code to hexadecimal, or probably decimal to hexadecimal, hexadecimal to decimal. In different ways we can try that. Okay, see you in the next video.